Alright, so we have a cool looking Diophantine equation, right? So what we did was we did a squared, so it has to be odd, right? Because this is odd minus even, and that equals and so then we know b has to be even because it's a squared is 1 mod 3, right? And then c is even, so let's just write c is equal to 2d, yeah? Because a squared has to be 1 mod 4, yeah? Wait, b can't be 0 because it's positive integers, so this is 0 mod 4, yeah? Okay, so a squared, so we can do this, so because it's even, we can do the difference of two squares, right? And this is 3 to the d plus a, to d minus a, yeah? And we know when we do this, like, one of them is a big power of 2 and the other one's just 2, yeah? And the 2 is going to be the 3 to the d minus a, because that's the smaller one, yeah? Then you get 3 to the d minus a equals 2, 3 to the d plus a equals 2 to the b, yeah? So, I think the most obvious thing to do here is just to eliminate a, right? You literally know that a and 3 to the d are basically the same thing, right? Does that make sense? And you can do it a lot of ways. I think that this way is most natural to me because this is like this is just a pure simplification of the original equation. See, because a equals 3 to the d minus 2, right? Yeah. So 3 to the d minus 2, you sub it in here, okay? So you get 3 to the 2d minus 4 times 3 to the d plus 4, yeah? Plus 2 to the b plus 1 equals 3 to the 2d, right? What do you do from that?
Get rid of the 3 to the 2d.
Yeah, there's some obvious things to do, right? Get rid of 3 to 2d. You get 2 to the b plus 1 minus 4 times 3 to the d plus 4 equals 0, right? Okay, then what do you do?
Move the negative over.
Move the negative over.
Well, we can divide by 4.
Yeah, I think divide by 4 is most natural. Divide by 4, so 2 to the b minus 1, yeah? Minus 3 to the d plus 1 equals 0, yeah? And I think that's a matter of good technique. You should also simplify, like once you make this substitution, you should make it into this equation as well. So this is 2 times 3 to the d, what? Yeah, equals 2 to the b, that's just the sum, plus 2. Or 3 to the d equals 2 to the b minus 1 plus 1. You know?
I already did that.
Oh, that's what both of these equations are. Yeah. So we don't have any. So this problem now reduces to a problem in two variables. You see? Yeah. Understand? So if you want to change the variables and organize it again, we know b is greater than 1, right? And it's even. It's greater than or equal to 2. Like we can write it as 2. So that's still, like, that's all the odd numbers, right? And then 3d, we don't have any assumptions on d except it's positive, yeah? So the equation becomes the 2 to the an odd b. Capital B is odd. What was the number again? Minus 3 to the d plus 1 equals 0, right? Yeah, so that's a simplified equation, you see? It doesn't actually matter if, like, you'd get to here no matter what. Yeah, what to do from here?
What? Capital B is odd.
Capital B is odd. But at the moment, I guess it's not so important whether it's odd or even. So, yeah, the odd thing is just to make the mod 3 work, right? Take it mod 4.
What's capital B meant to be? Where did you get it from?
Oh, it's because I had b minus 1, yeah? So capital B is just b minus 1. So it could be any odd positive integer. Capital B equals b minus 1. Yeah.
Wait, I got
Yeah, there's a few ways to finish
I
this.
got 2 to the B minus 1 equals A plus 1.
Yeah, so I mean, you'd rather get rid of the so the question is, would you rather get rid of the A or like a power of the 2? Like, would you rather get rid of the A or the B or the C? Yeah, I mean, you don't really know, but like, so you don't know anything about the A, right? Whereas you kind of know everything about the B and the C. Like, because that term is well known, right? It's just the power of 2. Like A, you don't know anything about it. Yeah, so it's a pure simplification. Like, effectively what you've done is you've logged that A equals 1, you see? Right? You've basically logged that A equals 1. So it's definitely a pure simplification. But you got a D now instead of a C, right? I guess you're not really seeing the parallels. Yeah, so if you realize this is the same equation with a equals 1, you can do the same things, right? So you take out mod 4, okay? So obviously b might not be more than 1, but that's only one case, right? If b is 1, d is 1, that's one case, yeah? But otherwise, it's 0 mod 4, right? So that means d has to be even, yeah? Yes? D is even unless b is 1, right?
Yeah.
Okay. And then d equals 1 is a solution we had before, right? So if b is greater than 1, d is even. And what do? You do the same thing, right? 2 to the b equals 3 to the 2. So you can write d as 2e, yeah? Minus 1.
Oh, and then you get 3 to the e minus 1 is like 2. Right?
Yeah, we could do that. So we get 3 to the e minus 1, 3 to the e plus 1, right?
Yeah.
This is 2, and this is 2 to the b minus 1, yeah?
So e has to be 1.
The e has to be 1. D has to be 2. And
So b, capital B has to be I want to right?
I think there's another approach here, but see, coming up with new ideas is always sort of,
So capital B is 3.
yeah. Then what's little b?
4.
Little b is 4. What's little d? What's little c?
Wait, have we had a big C?
Little c. What's little c? We found out little e, so what does that make little c? What does that make a?
4.
Little c is 4. And what is a? So 32.
7.
7. So it's 49 plus 32, 81.
Yeah.
Okay. Do you completely comprehend this question? Yeah. I think you could do some new things here, but why would you want to when you can use the old things, right? It's making the most of the old ideas. You could probably do like the 2 to the b. You could factorize it in a funnier way. You could do like 3 to the d minus 1, right? If you didn't know it was even, right? Because now 1 is any power. You could do 3 minus 1. And then do like 1 plus 3 squared. 3 to the d minus 1, you know?
Yeah.
So if you do that, the 2 cancels here. So you get 2 to the b minus 1. So now if you're assuming b is greater than 1, right? This is like even, right? And it's equal to sort of a bunch of odd terms. How many odd terms are there? How many?
So D has to be even.
Yeah, we had D was even, right?
So, but you did that by assuming D was no.
Now this one has no assumption on D here. So there's D terms here, right?
Yes.
So it has to be even. Yeah. Um. Yeah. Yeah, there's quite a few things you can do. You can kind of keep dividing. Yeah. Okay, I'm gonna talk about this some other time. Yeah, but you get the main thing.
Yeah.
Yeah.